Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah wa salatu wa salam ala rasulillah amma ba'd. In this tutorial, we will see how to interface an LCD with the microcontroller. So basically, there are two types of LCDs available in the market. The most common type that you see is the alphanumeric LCD, which has a matrix of dots. Using the dot matrix, you can display any character that you want. And the other type of LCD is the segmented LCD. So in this LCD, you have fixed defined segments or predefined segments, and you can only display these segments on the LCD, or these symbols which are available on the segments on the LCD. So first, let us see this, how to configure or how to use the segmented LCD. So in our mechatronic demo board in the lab, we have a segmented LCD, and these LCDs are simply LCD screens, and they do not have their own LCD driver or LCD controller. So this is the diagram of the segmented LCD that we have on the mechatronic demo board. And to control this LCD, some of the PIC microcontrollers, they have an LCD driver module. For example, PIC16F917 microcontroller. So we will use the LCD driver module of this microcontroller to control the segments and characters that are to be displayed on this LCD. So we have here mega symbol, kilo, ohms, milli, volt, ampere. So this is a 3.5 digit LCD. So we can display 3 digits here and a half digit here, and these predefined symbols of segments. Now to control this LCD, some of the microcontrollers, they have a built-in LCD driver module, and the microcontroller which came along with the mechatronic demo board is the PIC16F917 microcontroller. So this is the block diagram of the internal LCD module, and there are three main parts of this LCD module: the LCD data registers, LCD timing control, and LCD clock source. So LCD data registers, they control the pixels that are to be displayed on the LCD. And in this microcontroller, we have 24 LCD data registers, which allows 192 pixels to be controlled individually. And we have LCD control register, LCD phase register, and LCD segment enable registers. And we have the clock source. The LCD segment enable registers are used to enable individual segment bits. And if you look at the data sheet of PIC16F917 microcontroller, we find that here we have an LCD driver module. So this is available in only some of the microcontrollers. So this microcontroller, using this LCD driver module, you can control the segmented LCD. So it has all these registers here. So this is the LCD driver module block diagram, and you have LCD control register, LCD pre-scaler select register, segment enable registers, LCD segment enable registers, LCD data registers, and you find here LCD clock source selection. Okay, and you also find here the LCD segment mapping worksheet. This is the blank worksheet that we'll have to fill whenever we use this LCD driver module based on the hardware connection. So we can see the detailed diagram here. So the pin diagram of 16F917, it has several segment pins and common pins, and from the microcontroller, these pins are connected to the LCD screen. Now the LCD screen, The LCD screen has 14 pins. The first 4 pins are the common pins, and the remaining pins are the segment pins. So by using a combination of a common pin and a segment pin, we can display any character on the screen. And these are the LCD data registers. So there are several LCD data registers available in this microcontroller, and by using the bits of this LCD data register, you can switch on any of the segments on the LCD screen. So here we can see an example. In the LCD screen, pin number 14 is connected to these 4 segments: the kilo, omega, volts, and amperes. Similarly, pin number 13 is connected to mega, milli, diode, and antenna symbols. So if you want to display a segment, any of these segments here, we have to switch on one of the common pins and one of the segment pins. And this is given in the data sheet of the LCD screen. And here we can see pin number 14, it was connected to these 4 symbols: ampere, voltage, kilo, and the omega symbol. So if you want to display the ampere symbol, then we have to switch on pin number 14 as well as pin number 1, which is common one. Similarly, if you want to display the milli symbol, for example, then you'll have to switch on pin number 13 and COM3, which is pin number 3 here of the LCD screen. Now, these microcontrollers, in their data sheet, we will find an LCD segment mapping worksheet. This will be available in the data sheet of the microcontrollers, which has a built-in LCD driver module. So this is a blank LCD mapping sheet, and you can see these are the segment pins of the microcontroller, and these are the LCD data registers along with their bits. And on the top you have common pins of the microcontroller: COM0, COM1, COM2, and COM3. Now, if you want to display any segment on the LCD screen, first we will have to fill this LCD mapping sheet based on the hardware connection. Now, depending on this connection that we have seen in the previous slide here, we find that COM0 of the microcontroller is connected to COM1 of the LCD screen. Segment 1 of the microcontroller is connected to the RC, battery, minus, and the AC symbols. Now let's go back to the mapping sheet. So this is COM0 of the microcontroller. So here we have seen segment 1 is connected to RC, battery, minus, and AC symbols. So we will fill that in. So based on this connection, we will fill that in the LCD mapping sheet here. COM0 with segment 1. COM0 is connected to COM1, so we'll look at the COM1 column now. In segment 1, we have RC symbol here. So what we will do is, in COM0 of the LCD of the PIC microcontroller LCD mapping sheet, we will fill all these segments. So pin number 5 is actually connected to segment 1. As we see here, pin number 5 is actually connected to segment 1. So we go here, in segment 1, we'll write the same symbol that is given in the LCD data sheet in the previous table. Similarly, pin number 6 has this symbol, DH symbol, and this symbol is connected to segment 2. So we go to segment 2 and we fill the symbol here. Then again, 3A is connected to pin number 7, and pin number 7 is segment 3. So segment 3 will fill 3A here, and 3B is on pin number 8, and pin number 8 is connected to segment 11. So we go to segment 11 and we fill 3B here. Similarly, let's look at other examples here. So the milli symbol is in COM3 and pin number 13. So pin number 13 is segment 16. So we go to segment 16. This is segment 16 and COM3. COM3 is connected to COM2 of the microcontroller, because here in microcontroller the number starts from 0, COM0, and on the LCD screen the numbers start from COM1. So COM2 and segment 16, it has the milli symbol. Similarly, the mega symbol is in COM4 here. Okay, so we fill it here. So based on the hardware connection, so this is based on the hardware connection in the schematic diagram. Based on the hardware connection, first we fill this LCD mapping sheet, and then whenever we want to display any symbol on the LCD screen, we'll have to set these bits of the registers given here. So LCD data register, LCD data 2 register and bit number 5. If we set this bit, then the 2B symbol will be displayed on the LCD screen. Similarly, the milli symbol, if you want to display that, then LCD data 8 register bit number 0. If we set that bit, then the milli symbol will be displayed on the LCD screen. Now let's look at an example. So we have 3 digits here. These are 7 segment digits, and the segments of this 7 segment display is labeled as A, B, C, D, E, F, G. Okay, so this is digit number 1 and this is digit number 2, and you have one more digit here after that. So if you want to display, for example, number 7 on digit 1, then we'll have to set 1A, 1B and 1C, the segments 1A, 1B and 1C in the LCD mapping sheet. So we find that 1A, 1B and 1C are available here. So what we'll have to do is, in LCD data 2 register, we have to set bit number 6 and bit number 5, and in LCD data 8 register we'll have to set bit number 7, and at the same time we'll have to switch on COM0 and COM2. So this will display number 7 on the LCD screen. Similarly, if you want to display number 4 on the second digit, so we'll have to set 1B, 2B, 2C, 2F and 2G. So we find 2B, 2G, 2C and 2F are filled here. So we'll have to set these particular bits of these registers. So similarly, by setting any bit from this LCD mapping sheet, from these LCD data registers, we can display any character on this segmented LCD. Now, once you have filled the LCD mapping sheet and you know which registers you have to switch on and off to display any character on this LCD screen, then you'll have to write your own functions to control these registers. So here is an example to control these data registers. So the first function that we have written here is the clear LCD function. So in this function, all these LCD data registers are cleared. So everything will be cleared on the LCD. Then we have this LCD init function, and these numbers, they are given in the data sheet. So if we follow this sequence, we can switch on or initialize the LCD by sending a waveform patterns, certain waveform patterns to the LCD screen. So here we have defined a few variables that will be used to display the numbers on the LCD screen. Now this is the main function. This is the actual function that will display a number on the LCD screen. So in this function, we are sending the parameter n, which is a number. So the first thing that we do is we clear the LCD, then we take this number, and if this number is a 4-digit number, we have to display the numbers one by one on the 7-segment display. So in the example, we have seen how to display 47. So the first digit was number 7. So suppose if we send the number 47 here, so we mask the higher digit and we get only the first digit here, which is digit number 7. So on digit number 1 we have to display number 7. So by using logical AND with 0f, we remove the higher digit and we take only the lower digit, which is, if you AND any number with 1 1, then you get the same number, and if you AND it with 0, you get a 0. So we take the first digit, and in this switch case it goes to case number 7, and as you see here in case number 7 we have LCD data bit number 6, bit number 7, and LCD data 8, bit number 7. These bits are set as 1, so it will display or it will switch on segments 1A, 1B and 1C on that LCD screen. Similarly, for the second digit, we take the number once again and we shift the number to the right by 4 bits. So 47 became 04, and then once again we mask with 0x 0f, and then we display the second digit, and the second digit was number 4, so it goes here and it will set all these bits from these registers. Similarly, if we have a third bit, we can once again do the same thing for the third bit and for the fourth bit and so on. And we can also write similar functions to display the different characters or different symbols that are displayed on the LCD screen. Now the other type of LCD, the alphanumeric LCD, it has its own LCD driver connected on the back side. So we don't have to manually display as any segment or switch on any segment on the LCD screen. So what we do is we simply send an ASCII character, the ASCII values of the characters that are to be displayed on the LCD screen, and this LCD driver module, it will convert that into COM pins and segment pins to be displayed on the matrix, on the dot matrix. So between the controller and the LCD screen, there will be several common lines and segment lines, and between the controller and the microcontroller, we'll have data pins, we'll have enable pin, read write pin, and the register select pin. So normally the LCD has 14 pins, and these are the pins of the LCD screen. First is the ground, a VSS is ground, VCC is the power, VEE is to control the contrast of the LCD, and RS is register select, read write, enable, and we have 8 data pins. This is the internal block diagram of the LCD controller, and here we can see how to display any character on the LCD screen. So we have multiple segment lines and common lines, and by switching on particular segments and particular common lines, we can display the segment dots, and by using a combination of these dots, we can display any character on the screen. So this is just a general character map. In your textbook, chapter number 12, it explains all the pins of this LCD screen, and you can see the description of each pin of this LCD screen and of how to connect these pins of the alphanumeric LCD. So read these pages from your textbook to understand how an LCD works. Page number 474 to 478. So we can also send some commands to the LCD screen. So we can either send data to be displayed on the LCD, and you can also send some commands to be displayed to control the LCD screen. For example, clear the display, or return home, decrement cursor, increment the cursor, or shift to the right, shift display left, and display on and off, cursor on and off. So this is an example connection of an LCD with the microcontroller. So these LCD screens, they can be controlled in either 4-bit data mode or 8-bit data mode. We have 8 data pins, and out of these 8 pins, we can, if you want to use this as a 4-bit LCD, then we have to connect only the higher 4 bits of the data pins. So we can ignore, or we can connect the remaining 4 pins to ground, or we can simply keep them not connected. And some of the LCD screens, they have 16 pins. So the pin number 15 and pin number 16 will be for the backlight of the LCD. Now to control this LCD, we have to write several functions in C to send the data to the LCD driver. So we find that these functions are already available, and we can use these functions in our program, in our XC8 program, to control this LCD screen. So for example, first we'll have to configure in this header file, in this LCD header file. So this LCD header file, lcd.h, is already available on the internet. You can find it. And to use the functions of this header file, first we'll have to configure the pin connection of our LCD screen. So we'll have to define where we have connected RS, EN, and these data pins of the LCD screen. So RS is the register select. If you have connected this to RC0, pin number C0, port C, pin number 0, then we'll have to write latch C0 here, enable on latch C1, and these data pins, they are connected on RC4 to RC7. So depending on the hardware connection, we'll have to change the pin numbers of the port names here in this header file. And we also have to define the clock frequency used by the microcontroller. So here in this example, we are using 8 megahertz as the clock frequency for the microcontroller. So the first command, or the first function that you must call in the main program, is the LCD init function. So this function will initialize the LCD screen, and then we can use LCD command function to send any command to the LCD, or LCD clear function to clear the LCD screen, or we can use LCD write character to write a single character on the LCD screen, LCD write string to write a complete string of data on the LCD screen, and LCD set cursor to move the cursor to a particular location on the LCD screen. So this is an example program of how to display EE366 on the LCD screen. In MPLAB, when we start writing our program, we include these header files stdio.h, xc.h, and lcd.h. lcd.h is the header file which has those functions that will control the LCD screen, and config.h has the configuration bits. So in the main program, we first start with setting the oscillator frequency using the oscillator control register. If we copy 73 to this oscillator control register, then that means we are setting the clock frequency, internal oscillator frequency, as 8 megahertz. Unsigned integer A and character S, these are few variables that we'll be using. So twist C equals 0 because the LCD is connected on port C. So we have to configure this port as an output port. So this is the first function that we are calling from that LCD header file, LCD init function. This will initialize the LCD. And we want to display EE366 in the first line and microcontrollers on the second line of this LCD. So let us say 366 is a number. So we store this number in the variable A. A is unsigned integer, that means it is a 2-byte number. We store this in this variable. Now to display it on the LCD, we have to first convert this number to a string format. Numbers cannot be displayed on the LCD directly. They must be first converted to string format. So for that we use this function sprintf. So what this function does is it formats a string and copies that string to an output variable. That output variable here is defined as S, and this S is a string of 20 bytes. So in this function, the first parameter is the output string, which is here defined here, and the second parameter is the string that we are copying to this variable. So we'll have to display EE366. So in double quotation mark we write EE, then the number 366 is a variable. So that number, any variable, whenever you want to copy a variable, we specify the format here in the quotation mark. So since we are copying a number, a decimal number, so we have written here percentage sign and D. So D stands for decimal number. If you want to display a hexadecimal number, we write X here. Or if you want to display a floating point number, for example 3.14, if you want to display a floating point number, then we'll have to write F here. And you can find, if you search on the internet, the format of a printf function, you can find several specifiers that you can use with this function. So you can use C for character, S for string, D for decimal number. You can also specify how many digits it should display. So in this example, we are copying the variable A here. So after the comma, after closing this quotation mark, after the comma, the third parameter is actually the variable that will be copied in this location. So what this function does is it will copy EE, and whatever number you have specified here after the comma, that number is copied here. So EE366 will be copied to the output variable of the output string S. Now the next function that we are calling here is the LCD clear function, and LCD set cursor 1,6. So since we have to display EE366 in the center, and this LCD screen, it has 2 lines and 16 columns. So we want to display this on the first line, and since we want to display it in the center, so we are moving it to column number 6 to move it in the center. So LCD set cursor 1,6, it goes to the center, and then LCD write string S. So it will call this function LCD write string function from the LCD header file, and the string is already defined in the variable S. So that will be displayed on line number 1 and column number 6. Similarly, on the next line, we are displaying microcontrollers. So we can move the cursor now. LCD set cursor 2,1, that means second line, column 1, and LCD write string microcontrollers. This is just a built-in delay function from the xc.h header file. And since we don't have to do anything after this, so we simply write while 1, which is same as writing go to $, and then return and close the function. So in the lab activity, we have 2 sensors connected to the microcontroller, and an LCD is connected to the microcontroller. You have to take analog input from both these sensors and convert them into their digital format and display them on the 2 lines of the LCD screen. So you can display the LDR output here, light sensor, and display what is the value of the light, and temperature sensor, and you can display on the second line what is the temperature value. So these 2 sensors are connected, and we have to take their values, analog values, convert them into digital format, and display them on the 2 lines of the LCD screen. To complete this activity, you can take the help of this comparison chart between the assembly code and the C code. This will help you in converting the previous lab activity that you have written in assembly to its equivalent in C. So we start by writing the header files, and then we have the global variables, and then we set the oscillator frequency and the trace registers, and then the ADC registers, AD control 0, 1 and 2, and inside the loop we set go bit to start ADC conversion, then wait for the ADC conversion to complete, and then copy the result from the AD result high byte. We are copying to one of the port registers. So in this activity, instead of copying the AD result to latch B, for this activity you'll have to copy the result or store it in a variable and then convert that to string format using the printf function, and then display it on the LCD screen. And then after that you'll have to change the channel from here, from AD control 0. So once again you'll have to write AD control 0 equal, you have to change the select another channel for the next sensor, and then set the go bit, wait for the conversion to complete, and once again copy the result to a variable and display it on the second line of the LCD screen. So this is how you can complete the activity for this lab. Assalamu alaikum wa rahmatullahi wa barakatuh. Subhanallah wa bihamdihi, subhanakallahumma wa bihamdika, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilayk.